Welcome back. As promised, we're going to go over these numbers for the True Match box versus the actual breaks of the cylinders. So, as Chris just got done saying, you know, we broke the 24-hour cylinder with an actual strength of 3240. The maturity curve predicted the strength at 3172. That's 2%. Okay, that's a 2% variance, which is pretty good. Maturity will allow up to 10%. But with our system and how it's evolved over time, and if you do a very good job of establishing your curve, you can get numbers 1, 2, 3%, which is really good tight predictions. To get into where the cure box, where the temperature was a constant 70 degrees overnight, not exposed to the cold, the cylinder broke at 24 hours at 2540. So the actual was 3240 of what was in the wall, but the cure box that was at 70 degrees, which everybody would think, yeah, hey, that's pretty good, you know, even in the dead of winter and temperatures getting down in the 20s, we got cylinders at 70 degrees. We're still 22% off of what's actually going on in the wall. To go to the plywood box that was insulated with, blue board or green board fairly well, so it was tight in there, so any of the heat that was generated from the cylinders would have stayed in the box. The 24-hour break of those cylinders in that cure box, which you find on most projects, was a whopping 1,330 psi, or 59% less than what the actual concrete was. So that, that brings me to the question, why are we doing it? Now there's technology, the technology's there, and there are some limitations to doing true match, meaning that you have to have a power source and you have to have a constant power source with not a lot of power interruptions and stuff. And I understand sometimes all job sites don't make that available. However, I would challenge people on this. When you're talking about bridge decks and you're talking about precast and you're talking about some of these other areas where you can dedicate a power line, I really don't understand why you wouldn't want to know exactly what your concrete is doing at that moment in time. So technology's there. That's another discussion for another time. I would really like to see this industry modify what they're doing when they can do it, but cylinders in a well-insulated, undisturbed box, okay, which most of us are judged on, they're not even close to reflecting, and will never be close to reflecting what's actually going on in them, in that pour. Now, although we try to make sure that the prediction is lower than the actual, sometimes that's not the case. So, for example, when we broke the 4-day cylinder, we were predicting 5,480 psi, but the actual was 5,350. For again, just a 2% difference, but 2% the other way. And on 7-day, we had a predicted strength of 5,888, but the actual was 5,720, which was 3%. Still staying in that range of predictability of 2%, but on these two breaks, we were a little bit the other way. There you go, folks. Lots of interesting conversations can be spun off of this little video, and I hope that engineers and structural engineers and DOTs and other people actually start thinking about this, because it's time for us to jump out of the dark ages on cure boxes. Thanks a lot. We'll see you at the next one.